So therefore now we have analyzed the two sections, section 1 and section 2, which is selection 1 or first selection and second selection. If it was a green, the probability of him getting another green is 9/14. If it was a green, the probability of him getting a brown is 5/14. You realize I always starting by saying if, because I think it getting the gist right by starting there. If it was a brown, the probability of him getting another brown is 4/14. If it was a brown. So those two areas there, they kind of like separate because these are possibilities. Either this or that, you see? So that's why we have to start back fresh and put back the 15 and take out the 1 from the 5, and then we get 14 again. I've seen cases where some students went to 13, keep on subtracting. No, this is one possibility that can happen. And if it's that happened, that would be the figures. But what if it's not that and that would happen? That would be the figures, because this is displaying all what is possible. Now the outcomes now, that's where we're going to use the word and. What is the probability of him getting a green and a green? And as we say, you multiply along the root, multiply along the branches. Across must add up to 1. 9 and 5 is 14/14. 4 and 10 is 14/14. But along the branches, you multiply. And means multiply in probability language, or means plus. Either you get a green after a green, or you get a brown after a green. So you add. Either you get a brown after a brown, or a green after a brown. You add. But what about a green and a green? You multiply. 10/15 times 9/14. That's the probability of getting a green and a green. Or you can say then a green, then a green. A green in the first, then a green in the second. Getting 2 greens. What is the probability of that happening? You multiply. And here's the answer. Can somebody please tell me what is under this rectangle? Which letter come in first? Which letter come in? What, then what? Say that again. B and G. No. Okay, keep that thought, the second person. Keep that thought. Let's go back to the first answer. The second person. Because which letter happened first? B, exactly. B. Here, which letter happened first? G. So it's G, then B, isn't that so? Look at there, G, then B. Please don't make this confuse you, because this word is after. If it was a green, green happened first. If green, then B. So green, then B. Okay. Green, then B. All right, bear that in mind. So when you see reach there, you have to like switch. That's why you have to be able to read from any direction in mathematics. So that's why I'm starting in the middle. If green, then B. Green, then B. Be careful. So you just multiply. Well, this one is easy, right? B and B, isn't that so? Okay. B and B, B then B. Multiply. Anybody? Which letter comes first? G or B? Here. He says, someone says B coming first. B then G. Anybody agree or would like to disagree? Your colleagues, your peer says B is the first letter. B then G. Would you like to agree or disagree? Anybody? If you agree, say yes. If you disagree, say you disagree. I need some feedback. I'm waiting. I repeat, You agree, right? Because look at there, isn't that so? B happened first, yes or no? Okay, right. So you agree and somebody agrees, so yeah, you're very correct. If B, then G. So that's why I always start in there. If B, then G. So when you see that symbol anywhere, you can start by saying probability, you know, but you might not really get the sense by just starting and going from left to right. If you start with the if, and then you go to the right, if B, then G, to indicate that this happened first. Okay, that letter there is the condition, it happened first. So anytime you see that symbol anywhere from now, whenever you see that symbol again, because you may go into another, trust me, any profession you go into in university, you must end up in another statistics class, and most likely you will come across that symbol again. When you see it, start in the middle right there. If, just say if and go to that letter. If X, if Y, whatever letter is there, because it happened first. Always bear that in mind. If B, then G. Now when the and now, you're saying then. So G coming after, so B now will be first. B, then G. Here it is, B and G. And you just multiply and you get your answer. So here is the fully labeled tree diagram of the experiment. They call it a probability experiment of selecting randomly 2 cards from a container that has 10 green and 5 brown without replacing. All right, without replacing the first card. Whatever card you get, you did not replace it, and you're going to select another. Okay, so that's why you have the denominators reducing, because you did not replace the first card. Whatever, is it be green or G or brown, you did not replace it. So